Hello, today we're going to talk about where conic sections cross. You're going to use what you know about conic sections and what you know about solving systems of equations to find out how they might intersect with each other. This is section 10.6. Let's get started. We're going to do problems 1 through 4 together. We're going to see how they do cross. We're going to look at the physical way that they cross by drawing some pictures. Number 1, create a picture of all the ways a line and a circle intersect. We're going to do this first without a conic section, just a line. And we're going to do that with a circle. So we're going to do this with a sketch. We're not going to do this with something really technical. If your circle is not perfect, that's not a problem. You're just going to draw the best circle you can. And then I want you to take a line, draw a line and see where they can cross. The most obvious one would be right through there. And it crosses 2 times. Well, I could draw a circle and a line that don't cross at all. Then I would have 0 times. Is there another way that these circles and this line and circle can intersect? Well, if you remember back from geometry, they could cross 1 time. That 1 time is where the line is tangent to the circle. So we can cross 2, 0, or 1 time. Number 2 says to create a picture of all the possible ways a parabola and a circle can intersect. So I'm going to draw a circle and a parabola, and this is how the first one I drew. And that intersects 4 times. And so now I want you to pause this video, and I want you to draw other ways that a parabola and a circle can intersect. Come back and check if they're similar to what I have. All right, these are the other ones that I drew. I said that it can cross 3 times, 2 times, 1 time, and no times. Now, we can always turn those parabolas on their side or upside down. So there are other ways to draw this, but your parabola and circle can cross up to 4 and as low as 0. Let's do number 3 now. Number 3 says that we're going to create a picture of all the possible ways a parabola and an ellipse can intersect. So I want you to pause this video now and see if you can draw some possibilities of the way parabolas and ellipses intersect. Come back and check what I've done. This is what I've done. I have some possibilities. I'm going to draw bunches of ellipses first. I have some that cross 4 times, 3 times, 2 times, and no time at all. Remember that those parabolas can turn on their side and up and down. But we can have at most 4, and every number in between 0 and 4. Let's move on to number 4. I want you to create a picture of all the possible ways a hyperbola and an ellipse can intersect. Again, pause this video. Do this yourself and come check yours with mine. Your pictures won't be exactly as mine, but they will be similar. I have a hyperbola and an ellipse here. This crosses 4 times. Then I have a hyperbola and an ellipse, and they cross 3 times. I want you to notice that one's tangent. I have 2 times, 1 time, and none at all. The last 3 that we did here have similarities in the sense that they all can cross up to 4 times and all the way to none. Now, after doing numbers 1 through 4, I want you to realize that I did not give all the possible ways that conic sections can intersect. I didn't do an ellipse and a circle. I didn't do a hyperbola with a circle. But I did several so you can get the idea of how we're doing these and what we're doing physically when we move on to the more abstract algebra concepts. Now we're going to take conic sections and find where they cross, but we're not going to do that on a graph. We're going to do that by solving them algebraically. So we're going to do number 5. We're going to start off small, and I'm not going to ask you where they intersect, but I'm going to ask you if this point is a point of intersection, yes or no. So we have to decide if this is. We have an x value of 2. We have a y value of -5. And we want to know if this is where these two conic sections could cross. The place where a conic section crosses is where it has a common point. A point is where the x value and the y value would make it equal or make a true statement. So if I plugged in the x and the y value into this, and after I did all the addition, subtraction, and multiplication, if the answer equaled 0, I would know that that point satisfies that equation. If I did the same thing on this conic section or this equation, and the x and the y satisfied that equation and equaled 0 after I was done, I would know that this point is the intersection of those two equations. So let's do that together. I'm going to plug a 2 in for all the x's. I'm going to plug a -5 in for all the y's. Let's start with this one. 24 x squared. I could just do the x squared will be 2 times 2, which is 4, plus 12 times y squared, and -5 times -5 is positive 25, plus 191 times x, which is 2, plus 144, the y of -5, and -58. Let's see if that does equal 0. I need you to show me this step. I don't need you to show me any more. So you can get your calculator out and you can type all this in and see if you in fact get 0. Pause the video now and go ahead and do that on your calculator. After you're done plugging into your calculator, you should have got that this truly does equal 0. So this one is a point for that equation. But we need to check it for this equation. So we're going to plug it in for there. We're going to plug the 2 in for all the x's and a -5 in for all the y's. 12 times x squared, that's 2 times 2, would make 4, plus 12 times the y squared, which would be 25, plus 95 times the x, which is 2, 144 times the -5, and then positive, plus 182. Go ahead and plug all this into your calculator, and you should get a 0 if this point does satisfy the equation. So go ahead and pause the video and find out. Yes, this does give you a 0, and it does fit for both of them. It must work for both of them to answer the question. The question was, state if the point given is a solution to the system of equations. Since it does work for both, then your overall answer is yes. This time, we're not going to find out if one point works. We're going to find the points that work for all of them. We're going to find any point they do intersect. And we're not going to start with two conic sections. We're going to start out with a conic section and a line. The question you might be asking is, what kind of conic section is that? Well, we have both squareds, so it can't be a parabola. It has to either be a circle, ellipse, or hyperbola. But one of them is negative, so it has to be a hyperbola. So we're going to find where a hyperbola and a line cross. I want you to kind of picture in your mind a hyperbola and a line. How many points possible? Well, that line could go through 2 on this one, and maybe even 2 on that one. So we could have 4 points total. We could have a tangent on that one and 2 on that one. So we could have 3. We could have 2, 4, 3, 2, 1, or none. So let's see what we got. We're going to solve this by substitution. Solve that for x by moving the 2y to the other side. We'll have x equals 2y. We will then plug that 2y in for every x we see in that equation. Negative 4 times x squared, which is now 2y squared, plus 8y squared, minus 37 times the x, which is 2y, minus 6y minus 200 equals 0. I want you to notice down here that we're going to start small with a line and a conic section, so I don't want to start out too complicated, all right? I want you to notice right here that we only have one variable. Only have one variable. That's really important. We need to get rid of one of the variables, and we did. So let's simplify this. This right here is going to become 4y squared, and 4y squared times negative 4 is negative 16y squared plus 8y squared minus 37 times 2, 74y minus 6y minus 200 equals 0. Let's simplify this. These come together to be negative 8y squared. This comes together to be negative 80y minus 200 equals 0. What can we take out of all of them? Does 8 go into all of them? Yes, it does. We're going to take out a negative 8. I like to do my box methods without any negatives. So we'll have y squared plus 10y plus 25 equals 0. We're going to do a box method on that one. We'll have y and y, both positive 5 and 5. So we're going to have y plus 5 squared equals 0. Set one of those x, y plus y is equal to 0, and we'll have y equals negative 5. So we found our y value, but we are not finished. We have found a y value of negative 5, but we must find our x value. The best place to plug it in is right there. We're going to plug that negative 5 in for that y, and we're going to get negative 10. We have found an ordered pair where they cross. Let's go to the next one. Now we're going to find where two conic sections cross, and our goal is to find the ordered pair, but to make it easier, we're going to try to get rid of one of the variables. This time, we're going to use elimination, or what people call linear combination. We're going to look at the top one and see if there's anything that can cancel on the bottom. And I want you to look at the y squareds and the y's, they could cancel quite nicely. We just have to make one of them negative to let that happen. So I'm going to make the top, change all the signs, make that a negative, a positive, and a negative. And I'm going to rewrite those underneath here, underneath the correct ones. So this one I'm going to write underneath here. And this one I'm going to write underneath here because it goes with, it's like terms with that. This goes here. And this one goes there. Let's do elimination on this one. These cancel and those cancel, leaving me with 19x squared plus 114x and negative 133. Can I take something out of all those? I'm going to try 19. So get your calculator out and see if 19 goes into all of those. Yes, 19 goes into them all. Let's take a 19 out. 19 goes into that one 6 times. And 19 goes into that 7 times. We're going to do the box method on this one. We have x and x. What multiplies to be 7, that's 7 and 1. To make that 6 be a positive, the 7's going to have to be a positive, but the one has to be negative. So we're going to have x plus 7 and x minus 1. That equals 0, and our 0 property says that x plus 7 to be 0, x has to be equal to negative 7. And for this one, x has to be 1. So I have 2 ordered pairs this time. An x value of negative 7 and an x value of 1. We have to find this ordered pair where it crosses then. We have to find where it, let's plug it into the top one here. Let's plug the negative 7 in. We're going to have 8y squared plus negative 7 or minus 7 minus 16y plus 7 equals 0. It looks like these cancel out, and I'm left with 8y squared minus 16y equals 0. Take out an 8. Y squared minus 2y. Actually, let's take out an 8y. So we'll have y minus 2 equals 0. I'll get 2 answers. Set that equal to 0, so y equals 0. And set that one equal to 0, so y equals negative or positive 2. Now, we plugged only one thing in, but we got 2 answers. So that means we have 2 ways that negative 7 can cross with this. So we're going to have a 0 and a 2. We also now need to plug the 1 in. I'm going to need to get some space here. All right, let's plug in that 1. We're going to have 8y squared plus 1 minus 16y plus 7 equals 0. These are going to combine to become 8. We're going to have 8y squared minus 16y plus 8 equals 0. Let's take an 8 out of all of them. y squared minus 2y plus 1 equals 0. Let's factor that one. Y minus 1 and y minus 1. So y is going to be 1. We have one value here. This crosses 3 times. Let's do another one because that was kind of long, and I want to make sure you can get all the pieces. We're in Algebra 2 now. We're towards the end of Algebra 2. They expect you to know a whole bunch of things. We're going to find where these cross. We're going to use the elimination method. Y squareds will cancel, and I want you to notice that the 30y, or the y, will cancel. So and they're already ready to eliminate. So I'm going to just rewrite this one underneath its like terms. So let's make this go under the 3y squared. This one goes under the 17x. This one goes under the 30y. And this one goes under the 105. We're going to bring this down because there's nothing for it to subtract. We're going to have 16x squared, thus cancel. And that one does. We'll have 16x, and we'll then have negative 32 equals 0. We can take a 16 out of all of it. Let's factor this. We're going to have x, a negative and a positive, a 2 and a 1, so we can have a positive when we're done, equals 0. So x is going to equal two things. Set that equal to 0, and x is going to be negative 2. Set that equal to 0, and x is going to be 1. So we have some ordered pairs up here. So far we have 2 of an x value of negative 2 and an x value of 1. We're going to need to find out the y values. Let's plug it. This is a shorter one. Let's just plug it into that one. You can plug it into this one if you wanted. It wouldn't matter. I'm going to plug it in for the x's. There's only one of the x's right there. So here we go. 3y squared minus a negative 2, which is a plus 2, plus 30y plus 73 equals 0. Let's put those together. 3y squared plus 30y plus 75 equals 0. Let's take a 3 out. Y squared plus 10y. When you take a 3 out of that, you get 25. At any point, if you need to use your calculator and I don't stop to use it, please feel free to pause the video. Let's factor that. And we get y and y, plus and plus. What multiplies to be 25? That's 5 and 5, and yes, 5 and 5 makes 10. Either one of those, when I set them equal to 0, y will equal negative 5. So, when I plugged a negative 2 in, I got a negative 5. Let's clear some room here. All right, let's plug in the negative 1. Plug it into the same equation. We'll have 3y squared. We're going to plug it in for the x. And so I have a minus x, so minus 1. Plus 30y plus 73 equals 0. Let's combine those. 3y squared plus 30y plus 72 equals 0. Take a 3 out. We'll have y squared plus 10y plus 24 equals 0. Let's factor that one. We have 3. We have y squared, y and plus and plus. What multiplies to be 24? Well, 8 and 3, but that doesn't add to be 10. 6 and 4 does. So set that equal to 0, and y will equal negative 6. Set that one equal to 0, and y will equal negative 4. So we have two values for this one that we put in. So we'll have two ordered pairs with a 1. We'll have negative 6 and negative 4. We have found where these two conic sections cross. They cross 3 times. We have learned ways that conics can cross. We did several pictures to see that many of them can cross as high as up to 4 times and down to at least of 0 times that they could cross. We also found ways that we found the points where they did cross by solving substitution or elimination. I hope this has been helpful. Goodbye.